welcome back. I'm Mr. Franklin, and we're going to look at impulse by looking at a graph. Because some situations can be much more complicated than just plugging in some numbers. Okay? But first we're going to start with this. So we have a motor that is, we turn it on at time equals 0, and it's running at 40 newtons the whole time. So it starts at 40 newtons and runs for 4 seconds. Starts at 40 newtons, runs for 4 seconds. So mathematically we would just say impulse equals force times time, which equals 40 times 4, which equals 160 newtons times seconds. Okay? But we can also do this graphically. So from the graph, we have force and time. We can find the area shaded underneath our 40 up to our time. So we go length times height, and we have 40 times 4, which is the same thing that we just did, equals 160 newtons times seconds. Now, where this really becomes a great tool is when we get into different shapes, or the shape is not on 0. So now we have a triangle. We have a motor that starts at 0 newtons, so it's not running. We turn it on and we're running the time, and it ramps up to 50 newtons, and it runs for 10 seconds. So this should actually be, let me correct this, 2, 4, 6, 8, and 10. It runs for 10 seconds. Let's fix that on your graph, on the handout. Runs for 10 seconds. Then it achieves a maximum force of 50 newtons. Mathematically, we're not going to get into how to figure that out, okay? But we're going to look at it graphically, okay? So graphically, what's the area of a triangle? Area of a triangle equals 1/2 base times height. What's the base? 10 seconds. What's the height? 50 newtons. Okay? And we take 1/2 of that. So 10 times 50 is 500, and then 1/2 of that is 250 newtons times seconds. Newtons times seconds. Okay? So that's how you do that graphically. The secret here, though, is be careful and read the graph, because if this triangle starts here at 4 and goes to, let's say, 14, we have to go, what's our base? Our base is from 4 to 14, so our base is still 10. Does that make sense? So you have to be careful how long is your base really, okay? So now you have 3 more problems graphically that you can use to solve these problems, okay? So work through those and get a basic understanding of at least the mechanics of solving a problem of impulse, and then the next lesson we're going to really kind of put some meat on it and talk about what's really going on. All right, thank you.